welcome to Virtual Protocol Podcast.
Imagine someone just hands you the complete, highly classified blueprints to a state-of-the-art multi-billion-dollar spaceship.
Right, and they don't even want your money.
Exactly. They don't want a contract. They don't want a subscription fee. They are just handing you the absolute cutting edge of human engineering entirely for free.
Which sounds crazy, but that is essentially what is happening in the artificial intelligence world right now.
Yeah, with this brand new development called Kimi K3.
Yeah.
So today we are doing a deep dive based on a breakdown from the highly respected YouTube channel, 2 Minute Papers.
A really great channel, yeah.
Oh, the best. And the goal for you today, as you listen to this, is pretty simple. We're going to figure out what Kimi K3 actually is.
Right, and why it's basically breaking the fundamental economics of AI.
Yes, and what makes it so radically different from, the tools that are dominating all the headlines right now. So, okay, let's unpack this. Because the initial capabilities of this thing are just, they're staggering.
Oh, absolutely staggering. We are not talking about an AI that just, writes a polite email for you.
Right, or summarizes a PDF.
No.
Really.
This thing is capable of coding a mostly working copy of a full macOS operating system.
Which is just wild.
It's a monumental leap in logic because, when we usually talk about AI coding, we're talking about really isolated tasks, right?
Like asking it for a Python script to scrape a website.
Exactly. Or, debug a specific drop-down menu on a web page.
Sure.
Those are short, contained problems.
Mm-hmm.
But an operating system, that's thousands of interlocking processes.
Right. It's memory management, file systems, security protocols.
Yeah, user interfaces, and all of those have to talk to each other flawlessly without crashing.
Yeah, because they also showed it coding the complex simulation logic of an Animal Crossing style video game, right?
It did, yeah. And for an AI to generate that kind of architecture, you need a system that possesses a really deep, sustained understanding of massive amounts of code.
Right, because if it messes up the code for the virtual real estate market in the game...
Tom Nook is going to start charging infinite bells for a digital tent.
Exactly, and the whole game just crashes instantly.
Right, let's hope we avoid an AI-generated Tom Nook monopoly. But jokes aside, the level of sustained reasoning required for those tasks means Kimi K3 is performing very, very close to the level of frontier systems.
Okay, and for those of you following the industry, you know that frontier systems are like the absolute apex predators of the AI world.
They are the multi-billion-dollar cutting-edge models.
Built by massive tech corporations. And usually, those frontier models are locked down tight.
Oh, incredibly tight.
Like, we constantly hear about them facing potential bans in certain regions, or they're hidden behind expensive corporate paywalls.
Right. You can interact with them, sure, but you never actually get to see how their brains work.
Never. But here is the massive pivot with Kimi K3. It's not locked away behind some corporate API firewall where the company can just change the rules tomorrow.
No, it's not.
Kimi K3 is an open weights model. We can download it. We can own those weights for free forever. Nobody can take it away.
What's fascinating here is the ideological shift this represents. Yeah. When a model is open weights, it means the core mathematical brain of the AI is handed directly to the public.
Yeah.
You aren't just renting access to a corporation's server anymore.
You're given the brain itself.
Exactly. It democratizes access to frontier-level technology, and it completely bypasses those traditional corporate gatekeepers.
Right.
For a researcher in a university lab or, an independent developer, this is like bypassing a massive security clearance and being handed the keys to the most advanced laboratory on Earth.
Okay, I have to stop you there, though, because I'm thinking about this practically.
Sure.
You say we're handed the keys, and if you are listening to this right now, you might be thinking, amazing.
Yeah.
Let me just download this super genius AI to my laptop and have it code me an operating system by lunchtime.
Right, yeah.
But there is a glaring physical problem here. If a system is smart enough to code an entire Apple operating system from scratch, how on earth is a normal person supposed to actually run it? There's got to be a catch.
Oh, there is. The catch is, gravity, basically. The sheer physical reality of the model's footprint.
Because the actual specs for Kimi K3 from the source describe it as stupendously, humongously big.
Yeah, that's a good way to put it. We are talking about 2.8 trillion parameters.
Wow, 2.8 trillion. Just to level set for everyone, you can't just drop a 2.8 trillion parameter model onto a standard hard drive and expect your graphics card to handle it, right?
No, your laptop wouldn't just freeze. It'd probably catch fire and, dim the lights in your entire neighborhood.
Right, it's massive.
Let's define what a parameter actually is, just because that number gets thrown around a lot in these discussions.
Yeah, that would be helpful.
Think of a parameter like a synaptic connection in a biological brain, or maybe like a tiny tuning knob.
Okay, a tuning knob.
Right. Every piece of knowledge, every rule of grammar, every single concept of coding logic that Kimi K3 has ever learned is stored across these 2.8 trillion tiny digital knobs.
Right.
So to ask the AI a single question, a computer has to load all 2.8 trillion of those knobs into active high-speed memory and do math on them simultaneously.
All at the same time.
Yes. The hardware requirements to do that are astronomical. You don't just need a good gaming computer. You need literally a warehouse filled with liquid-cooled servers.
So for you listening, the immediate question is probably, how does this actually benefit you if you physically cannot turn the thing on in your own house?
Right. But there are a few very practical workarounds right now.
Yeah. First, from what I understand, you can try it for free on the web, assuming the servers aren't overloaded.
Yes, depending on availability.
And second, you can access it via an API.
Exactly. Where your computer essentially just sends a text request to a massive server farm that is running Kimi K3. It gets the answer and sends it back to you.
Right. And using their API is way, way cheaper than paying for current corporate frontier models, isn't it?
Oh, absolutely. Which creates this massive economic ripple effect.
How so?
Because even if you personally never log on to use Kimi K3, its mere existence out in the open market forces token prices down across the entire AI industry.
Oh, I see. Let's clarify tokens really quickly. When we say token prices, think of a token as a single word or like a piece of a word, maybe a syllable that the AI either reads or writes out.
Right.
Every time an AI generates a word, it costs a fraction of a cent in computing power. And because Kimi K3 is so capable and its API is so incredibly cheap, it's driving that cost per word down for everybody else.
It really is a massive price disruptor. It breaks the monopoly on high-tier intelligence.
Wow.
But, the API isn't even the most exciting part for me.
Oh.
No, the most crucial workaround for the size issue is a process called distillation.
Ah, right. Distillation.
Yeah, these unwieldy, massive models are regularly distilled down into smaller, much more accessible versions, and they keep a surprisingly similar level of capability.
So going back to our analogy from the beginning, distillation is such a critical concept here. We established that having Kimi K3 as an open weights model is like getting the blueprints to a massive spaceship.
Right.
But you don't have a launch pad or the rocket fuel. You can't fly it. But through distillation, how do we get from that massive spaceship down to like a consumer-sized drone that you or I could actually fly on our laptops?
It's a great analogy. Distillation is basically having the massive spaceship's onboard computer teach the smaller drone how to fly.
Oh, interesting.
In AI, you use the massive, brilliant 2.8 trillion parameter model to generate incredibly high-quality training data. Or you have it directly grade and guide the learning of a much smaller model.
So it's tutoring it.
Exactly.
Yeah.
You are capturing the essence of the intelligence, the refined logic, the step-by-step reasoning, and transferring it into a smaller brain. You strip away all the bloat. So a trivial-to-run distilled version of Kimi K3 that you could actually run at home, that is very likely on the horizon.
Okay, so distillation gets us a smaller, more efficient drone, but that actually exposes another massive physics problem to me.
What's that?
Well, whether we are talking about the massive 2.8 trillion beast or a smaller distilled version, making an AI read thousands and thousands of lines of macOS code without crashing its memory is an incredible hurdle.
Oh, it's a huge bottleneck.
Right. How is Kimi not just freezing up when you give it a massive project? The sheer computational math happening every time you ask it a question in a really long conversation, it should theoretically bring it to a crawl.
It should. And that brings us to the underlying mechanics of how they actually made this work. The developers shared their secret sauce.
Which is incredibly rare in this industry right now.
Very rare. But they shared it, and the first ingredient in their architecture is something called Kimi Delta Attention, or KDA for short.
Right. And the breakdown from 2-Minute Papers uses a brilliant analogy to explain how standard AI processing worked before KDA.
Oh, the meeting analogy. I love this one.
It's so good. Imagine being in a massive corporate business meeting. But before anyone is allowed to speak or share a new idea, every single researcher in the room has to manually reread every single document that everyone has ever produced up to that moment.
Which is insane. That's not a productive meeting. That is
Yeah.
literal torture.
Exactly. It's computational torture, and it scales horribly.
It really does. In traditional AI architectures, as your conversation gets longer, the AI has to constantly recalculate its attention across every single word that has been said previously.
Every single word.
Yes. And the math required to do that doesn't just increase steadily, it increases quadratically.
So it spikes.
It requires a staggering amount of compute just to remember what was said 5 minutes ago in a long discussion.
Okay, and here's where it gets really interesting, because KDA completely flips that script.
It does.
Instead of the torture meeting where everyone rereads everything, KDA introduces a carefully updated notebook. You only read and update the latest notes. And crucially, it lets old, irrelevant notes gradually fade away.
Right.
Think about it like cramming for a massive college final exam. You aren't going to sit there and reread all 50 of your textbooks cover to cover every single night.
You'd never sleep.
Right. Instead, you make a master study guide. You update that guide with the new synthesized facts you learn, and you let the highly specific, irrelevant details from the first week of class naturally fade from your active brain.
So you have room to process the complex new stuff.
Exactly.
If we connect this to the bigger picture, managing memory context is the ultimate bottleneck in modern AI development.
Yeah.
When an AI processes text, it has a context window, which acts as its short-term memory. As that window gets filled up with huge documents or, a massive code base, the traditional attention mechanism becomes overwhelmingly slow and expensive.
Right, the quadratic math problem.
Exactly. So by implementing Kimi Delta attention, they allow the model to actively summarize and fade older information. This is a massive leap in processing efficiency.
Wow.
It finally allows the system to handle a very long discussion and actually contribute meaningfully without completely freezing up or just, running out of memory.
But wait, as a listener, you might spot a logical flaw here, because I definitely did when I was reading through this.
Okay, what's the flaw?
If KDA is letting old notes gradually fade away to save on processing power, what happens when the AI desperately needs to remember a crucial, highly specific detail from early on in the project?
Ah, yes.
Right. If it's coding an operating system and a foundational line of code from 50 layers ago is suddenly critical for a new security feature, but KDA let it fade the whole OS crashes, the AI hallucinates a completely broken response.
You've hit the nail on the head. That is the exact inherent vulnerability of a fading memory system.
Yeah.
And it's precisely why the developers could not rely on KDA alone. They introduced the second vital ingredient to their secret sauce: attention residuals.
Okay. And the visual for attention residuals is kind of like a document being passed through various departments in a massive company, right?
Yes, perfect way to picture it.
Department 1 does their work, passes it to 2, then to 3. In a normal fading memory system, when the document finally reaches Department 4, they only get the absolute latest, heavily summarized version of the document.
Right.
But with attention residuals, Department 4 gets the newest version, but they also get the complete version history attached to it. They can actually see exactly how the document changed and evolved over time from Department 1.
Exactly. And let's dive into how that works physically in the hardware, because that is where the real magic happens.
Please do.
Remember how we said standard attention forces the GPU to recalculate every single word quadratically,
Yeah.
taking up massive amounts of
You mean
memory?
the torture meeting?
Right. Well, attention residuals bypass that. When Department 4 or Layer 50 of the neural network needs that old information, it doesn't recalculate the whole conversation.
It doesn't.
No, it acts as a targeted retrieval system. It pulls highly compressed, previously calculated states directly from earlier layers.
Oh. So it's not recalculating the math. It's literally just pulling a file from an archive.
Exactly. It creates a perfect balance.
That makes so much sense.
Kimi Delta attention maintains and actively corrects the current memory, keeping the immediate processing light and incredibly fast. But simultaneously, these attention residuals act as a lightweight backup system.
So you aren't forced to constantly hold every tiny detail in your active high-speed RAM.
Right, but you have the architectural ability to instantly recall the exact original context when you actually need it.
Wow. And combining these two completely different ideas, the fading memory of KDA and the historical retrieval of attention residuals result in a massive, measurable leap. We are looking at a 2.5x improvement in scaling efficiency over their previous model, Kimi K3.
It's a huge jump.
But I want to pause here because numbers like 2.5x efficiency get thrown around in tech marketing constantly.
They really do.
So, what does this actually mean? Does this mean Kimi K3 is 2.5 times cheaper for you and me to use? Or does it mean the AI types out its answers 2.5 times faster?
Neither. And it is vital to understand the difference here. A 2.5x improvement in scaling efficiency does not equate to a price drop or a speed boost at the end user level.
Okay, then what is it?
What it means is that during the massive months-long training phase, the developers get roughly 2.5 times more learning progress out of the exact same amount of computational power.
Wait, wow. Okay, so if they spend $1 million on electricity and supercomputers, the AI gets 2.5 times smarter for that same $1 million compared to the previous generation.
Exactly. It is a phenomenal return on investment because training a 2.8 trillion parameter model is an industrial scale operation.
It can.
It requires tens of millions of dollars in electricity and specialized hardware. So by increasing the learning progress by 250% for every dollar spent on computation, they have radically shifted the fundamental economics of how these giant digital brains are built.
That is insane.
Yeah, getting that kind of bump over just a single version number is almost unheard of in this space.
It really puts into perspective why the industry is paying so much attention to this. So we've unpacked the technical breakthroughs. We understand why it's so massive with its 2.8 trillion parameters and how it manages to process all this data without drowning by balancing KDA and attention residuals.
Right.
But I want to zoom out for a second and look at the real-world impact. Because with all these puzzle pieces put together, we are looking at something being described as the golden age of open science.
It is hard to dispute that framing, honestly. There is a profound, compounding truth about the open source community. Every single research paper, every new architecture, and every open release like Kimi K3 makes all the other open models work better.
Right, they all build on each other.
Exactly. We are rapidly moving away from a paradigm where human knowledge and AI breakthroughs were siloed within 3 or 4 competing megacorporations.
Yeah, locked in those black boxes.
We are entering an ecosystem where researchers are actively building this technology together across the planet.
And we get all of this cutting-edge logic for free. And the real-world applications are happening right now. This free, open technology is actively helping doctors analyze medical data.
Right.
It's helping independent scientists run complex simulations, and it's allowing students globally to learn from frontier-level intelligence.
That's amazing.
But going back to our earlier point about the hardware limitations, I'm curious about the mechanics of this open science. If a medical researcher in Brazil wants to test this 2.8 trillion parameter beast, how are they actually doing it without a warehouse of liquid-cooled servers?
That is where cloud computing platforms specifically tailored for artificial intelligence come into play. A major part of this open science revolution relies on platforms like Lambda, which scholars use to actively participate without needing to own the hardware themselves.
So they essentially just rent a fraction of a massive supercomputer in the cloud for a few hours.
Exactly. Researchers use platforms like Lambda to reproduce these massive AI research papers in a matter of minutes.
Which is wild when you think about it. You read a white paper about a new breakthrough in Kimi K3, and instead of just, trusting the math, you can spin up a server on Lambda and test the exact code yourself moments later.
Yes. And it goes beyond just testing code, too. Platforms like Lambda allow users to train their own bespoke models, fine-tune existing ones, or run complex inference tasks.
Right. Let's define inference really quickly for everyone. When we talk about training, that is the months-long process of teaching the AI how to think, right?
Right.
But inference is when you are actually using the finished model to infer an answer, like having it generate a text-to-image graphic, or render a video, or answer a coding question.
Precisely. Running complex inference, or powering advanced AI agents and chatbots like DeepSeek natively, requires incredibly powerful hardware.
Which most people don't have.
Right. Cloud platforms provide on-demand access to the specialized NVIDIA GPUs required to run these experiments reliably and at super speed. It removes the geographical and financial barriers to entry for global science.
It levels the playing field completely.
It does. This raises an important question about the current cultural shift in the tech world.
Yeah.
For decades, the tech industry was defined by closely guarded corporate secrets. Think of the algorithms powering search engines or social media feeds.
Oh, yeah. Nobody knew how those work.
Right, they were locked in a black box. But now we are seeing a collaborative ecosystem where top-tier researchers are literally publishing their secret sauce, like the complete math behind Kimi delta, attention, for the sheer benefit of global scientific progress.
It's a fundamental realignment of how technological advancement is achieved.
It really is.
It truly feels like a golden age. So to bring this all together for you, today we have explored a jaw-dropping AI system, Kimi K3, that is capable of coding a whole macOS environment and complex logic games from scratch.
Yeah.
We grappled with its absolute unit of a size at 2.8 trillion parameters, and we decoded the genius of its internal architecture, the delicate balance of Kimi delta. Attention letting old notes naturally fade to save memory, while attention residuals keep the vital history alive.
Resulting in that massive 2.5x boost in learning efficiency.
Exactly. And most importantly, we saw how this open weights model is fueling a global collaborative era of open science, supported by cloud computing that empowers doctors, scientists, and students everywhere.
It's a vast amount of information to process, I know.
It is.
But as we reflect on the brilliant architecture of Kimi K3, I want to leave you with one final thought to ponder.
Okay, let's hear it.
We learned today that Kimi K3's Kimi delta attention specifically allows old nodes to gradually fade away so the model can process massive amounts of information efficiently. It actively sacrifices perfect, permanent retention for the sake of immediate high-speed processing power.
Yeah, like cramming for that exam.
Exactly. Now, if the future of highly efficient, super-intelligent AI relies on systems that actively forget or let early information fade, which, by the way, is strikingly similar to how human memory works, could this mean that tomorrow's AI models might eventually suffer from the exact same flaws as human eyewitness testimony,
Oh, wow.
where crucial foundational details aren't just misplaced, but naturally and permanently lost to the passage of time?
That is a wild thought to end on. If we engineer them to process information like us, maybe they start forgetting like us too.
It's definitely something to think about.
For sure. Thank you so much for joining us on this deep dive into Kimi K3. Stay insanely curious, keep exploring, and we will see you next time.